Hello. So we're going to do the second one you sent me. So it's factoring this polynomial over here. So the trick to starting it is to use the graph. So we know for sure that this thing has two roots that we know about, and those are -5 and 3. So that's always the first step, the way we've been doing it, is just to use the graph to just visually look, okay, these are the x-intercepts where the roots are. And then we actually know that there are two more because a fourth degree polynomial has to have 4 roots. So we start with those ones and we start kind of peeling them off. So I forgot what they were already. -5 and 3. So we start by dividing it out. And we had a way to divide out the factors. So we know from that it has factors of x plus 5 and x minus 3. But we don't really need that to do the synthetic division. So synthetic division was this thing. So to factor out stuff like that, we used this process. And it's just a clever way somebody came up with to do long division without really doing it. So these numbers come from coefficients of f, and you just take one of your roots, whichever one you want. We could have used -5. I just used the positive one because it seems simpler. And then you do this process. So refresh yourself on this process. So the 1 comes down and we multiply by 3. So we keep adding these and then multiplying by 3. 3 times 5 is 15. -11 plus 15 is 4. 4 times 3 is 12. 8 plus 12 is 20. 20 times 3 is 60. -60 plus 60 is 0. And that's good because that 0 is the remainder. So if you get a 0 there, you did it right. Okay, so now there's a couple different ways you can go about it. You could take these new coefficients here and synthetic divide -5 out. So I'll show you both ways. So we take 1, 5, 4, 20. So we used our one root. We can use our other root on the leftover coefficient. So the 1 comes down. That gives you a -5. That gives you 0. That gives you 0. That gives you a 4. That gives you -20. And that gives you a 0. So it's a little weird, but so this is once we factor it out, this is a third degree. These are the coefficients of a third degree polynomial. And these are the coefficients of a second degree. I'll show you the other way to do it. Right from here, we would say, okay, we have now factored f into x minus 3 times x cubed plus 5x squared plus 4x plus 20. And if we want to factor that part of it further, which we do, we can actually use factoring by grouping. So hopefully you remember that. So we factor an x squared out of the first two terms, and we factor a 4 out of the second two terms. I'm sorry, that should be a 5. So this is one way we have to factor a third degree polynomial just by hand without doing the synthetic stuff. And that corresponds with, okay, that means we factored it into x squared plus 4 times x plus 5. So this x plus 5 we already kind of knew about because we knew we had a factor of x plus 5 from the graph. This x squared plus 4 corresponds with these coefficients. That's the x squared term, the 0x term, 4. So whichever way you're more comfortable with doing, obviously, is totally fine. Okay, so we're not done. So our other two roots, our secret ones, or they're complex, are found by solving that for x. So the way to do that is just to move the -4 to the other side. X is plus or minus square root of -4, which is plus or minus 2i. So the reason we only saw 2 roots on the graph is that two of the roots are complex and 2 of them are real. So the whole thing factors into x plus 5 times x minus 3 times x minus 2i times x plus 2i. And then just to wrap it all up, the roots are x equals -5, 3, 2i, and -2i. Okay.